It never occurred to me that these could fail and come back to haunt me in such a major way. Hey, it's Pete. Welcome back to the workshop. For the last few weeks, I've been continuing on my work for the Centroid Acorn retrofit on our DynaMyte 2800 milling machine. I've been working in 3 separate areas, so let's get right into it. The first project I tackled was getting the tool probe hooked up. This is the original tool probe that was delivered with the DynaMyte 2800. All I had to do was dig into the electronics to figure out exactly how it was wired internally so that I could adapt it to the Centroid Acorn. The first thing I needed to do was pop a hole in the side of the cabinet to mount the connector for the tool touch-off probe. I taped up all the electronic bits so I wouldn't be throwing chips into them, and then put the hole in with a step drill. I rewired the probe to use an aircraft-style connector. There's just 2 circuits in the probe, a conductive switch and an LED. Then I used my telescopic magnetic tool to clean up all the chips in the bottom of the cabinet. The final step was to find an unused input on the Acorn and wire the probe in place. This is a conductive style probe that I'm going to be wiring into input 4. It closes when triggered and it has a height of about 0.97 inches. I'll dial this in further once I get to using it. I'm going to be using this to set my work offsets as well as measure tool heights. I took a quick trip into the setup screen and made sure that it was configured properly for the new touch-off. I wanted to do a quick test to set part 0 for the Z-axis of the G54 work offset. Alright, here goes nothing. Hitting auto. Is this working? It's registering there. There we go. Set at 0.97, which is what I had set in the setup screen. That seems reasonable. That you would use anywhere. So let's try it with a vise in there. Close. Then I did a quick test to raise my tool 2 inches above my part 0 and verified that it was correct. Alright. Next I wanted to give a quick test of the tool height offset system. I just played around in here a little bit. Initially I set my Z reference to the same position as one of the tools. I don't know if in practice if I'll be using a reference tool or an imaginary tool, but this was just a chance to get a feel for how it worked. I just did a quick test setting up 2 tools, putting a 1/4 inch end mill into tool holder number 1 and a 3/8 end mill into holder number 2. So that all seems to be working as expected, and I am going to chalk that up as a win for this week. At the end of the last installment of this project, I had reached out looking for some help, looking for the dimensions on the original chip guard that went on the table of this machine. When I received the machine, that chip guard was missing and I wanted to duplicate it. I had a few offers to provide me with the dimensions, but one individual went way above and beyond the call of duty and provided me not only pictures of the guard, but created a 3D model for me to use. He also gave me a clear view of the underside of the guard, which was something I had never seen before, and cleared up quite a few details as to how the guard was actually mounted to the table. I'm not sure if this individual wants to remain anonymous or not. I never got a response on that, but thank you very much. I decided to make a full-size model of the chip guard out of poster board. This gives me the opportunity to double-check all of the measurements and see that everything would fit properly, and if anything looked like it needed to be modified, I could address it from there. I used 123 blocks and any other piece of right-angled metal I could find laying around the shop, along with magnets to hold everything in place while the glue set up. I hope you're inspired here to pursue your projects, overcome the obstacles, and tackle the to-do list in your workshop. Click that subscribe button, then follow along as I tinker on projects, sharing my successes and failures along the way. Yeah, our only problem is right here. We're going to either lower this or raise that. We're not off by much though. Flange here. And a flange right here. That's all that really holds it. Alright, well our dimensions look good. The next system I wanted to get up and running was the automatic lubricator. This uses a motorized one-shot pump to periodically pump oil into the ways of the machine. I had to replace a missing fitting as well as 2 broken oil lines. I love this tubing cutter. It's cheap and leaves a clean cut. I'll put a link to it as well as some of the other tools I used in this project down in the video description. The pump can be operated manually by pulling up on a plunger. This part worked fine. Here's where things started to go south on me. The y-axis was clearly getting oil, but I was getting no oil to the tubing that feeds the x-axis, and I wasn't entirely sure about the z-axis. I had to remove the counterweight cover to check the oil flow there. If we pull this set screw here, we're going to have oil. So the oil comes up the back end tubes into a fitting here, and then it's drilled that way. So we just barely miss it here, I think. But it looks like we should have oil there, although I'm not seeing any signs of this being damp at all. So we have oil flow on both sides of the y-axis. We have it on only the right-hand side of the z-axis. Nothing on this side, although the oil is making it all the way up to here, so I'm not sure what's going on there. And then we don't have anything on the x-axis. The big problem here is I need to get into the underside of the base of the machine, which means I have to lift up the cast iron chip tray enough to remove 6 bolts. The majority of the oil distribution system is inside the base casting, and this will give me better access to the Z-axis oil metering valves. So it became apparent that some of the metering valves had failed. These are designed to provide a constant back pressure to the oil system. Without these, the oil would take the path of least resistance, and some parts of the machine would receive a ton of oil while other parts might receive no oil at all. They do this by having a very restrictive oil path. Unfortunately, this makes them very prone to clogging. I thought I would try to resurrect these with purple power in a heated ultrasonic cleaner. I suppose it was worth a try, but ultimately it didn't have any effect, so I went off looking for replacements. When replacing these, you're supposed to do all of them at once so the flow is matched across the system. For me, that meant ordering 6 new fittings. So the replacement metering units arrived today. I'm going to get these installed in the machine and try to get that lubrication system back up and running. This job would have been so easy when the machine was all in pieces. Working on it like this was a major pain and turned what would have been a 20-minute job into a 2-hour job. This is something I should have tackled at the very early stage of the project. It never occurred to me that the metering orifice could fail in this way and come back to haunt me like this. But we now have oil flowing to all 3 axes of the machine and managed to turn that mistake into a win as well. If you want to catch another great project, click that link to the left and I'll see you over there.